Good day to you, my dear friends. It's time to solve some LeetCode problems. Yes. And yesterday we stopped with this problem, I believe. Minimize string length. Let's go to my last submission from yesterday. Yes, let's take it. So, minimize string length. If we go to the solutions section, you're gonna find these two solutions. Well, they're not bad, you know. Split unique length, bytes unique size. I showed you this solution too. It was like this: chars unique length, right? But I do not like these lazy solutions, you know, using all these built-in methods. Like, it's not awfully bad because, well, all these methods doesn't affect our big O too much. I mean, we still have to iterate through every character. So it's gonna be big O of n in terms of time. But what about space? You know, in my solution I used hash to store information about used letters, and one may think that using hash is a problem, but actually it's not, because how big can it get, this hash? I mean, it can't be bigger than 26, right? Because there are 26 letters in English alphabet. And the size of this hash, it doesn't depend on the size of our array. The length of our string, it is pretty much fixed. So using hash is great because, you know, we already convert our string into an array, and it's gonna be a big O of n for space. That's what I thought yesterday, because I thought we definitely have to convert our string into an array of characters. But today I thought, well, why do we have to do that? First of all, let's simplify this thing. A little bit. It doesn't matter what we store, you know, as a value for all these hash keys, because we don't even check. We just want to know if we have this key or not. So let's put our count there all the time. So it can be something like this, and we can simplify it even more, do some kind of a one-liner. Well, not a one-liner, of course, because we have all these variables, but still, I'm a sucker for short solutions, you know. Let's check. Well, great, but now, do we have to convert string into an array? Let's just use while loop. Now let's introduce index variable equals to 0, and while as index, we're gonna do the same thing practically, but instead of letter we're gonna use as index. And in the end we are going to +1 our index Let's check. Great, and let's simplify it even more. Not simplify, no. Just get rid of one of the lines. Excellent. So I think this is the best solution. Why? Because we do not create an array here. And our hash can be only, its maximum length can be 26. So in terms of time it's big O of n, but in terms of space it looks like big O of 1. I'm not sure, but if this is true, then this is the best solution and I should upload it. I'll think about it some more, but yeah, I like this one. Now, no. Let's investigate one of the problems that I already solved in the past, but that we haven't discussed yet. It's gonna be what? Final value, yes, it was shuffled the array yesterday. Today it's final value of variable after performing operations. And I wanted to say that we are already halfway through the first page, but no, not yet. So 2011 final value of variable after performing operations. So there is an array of operations. And there are 4 kinds of operations. Well, actually 2. And the first one is we have to increment the value of x by 1 if it's an operation that looks like plus plus x or x plus plus. And we have to decrement the value of our x by 1 if operation equals minus minus x or x minus minus. And of course, the easiest solution, the first one that comes to mind, and it was my first solution, it looks like this. Well, we just iterate, and if it's minus minus x or x minus minus, we do minus 1, otherwise we do plus 1, and it's alright, you know, but there is a much better way. Let's use a sum method. Now, sum method is somewhat equal to reduce or inject method that we used yesterday and the day before, but we do not need to specify accumulator and starting value for sum method. We just need to specify what do we want to add. You know, like if we have an array like 1, 2, 3, we want to sum it, and without arguments, without the block, it's gonna be the same as this block, just summing up the values. I get 6, but we do not have to use the element itself. We can just use like 1 for every element, and then it's gonna be the same as using count. You're gonna get 3, or we can use minus 1 and so on and so forth. How can it help us? Well, let's do this without _1. for now, just to make it clear. Let's call it op. It's our operation. What say these two have in common? That's what the character in position 1 is plus, you know, because in position 0 it might be plus or x, in the last position it might be x or plus, but in the second position for both of them it's a plus, and for both of these it's not a plus. So if the first, no, not first, in first position, if character in first position is plus, oh no, we are checking for this. We're gonna sum 1. If not, we're gonna sum -1. Ain't it beautiful? Ain't it simple? Ain't it elegant? I love this solution. That's right. And now we can use our favorite _1. So many ones in this line. Oof, it's practically unreadable for an untrained eye. And I believe this is the best solution for that problem. Great. Now let's solve something new. Someone else, someone new. Oh, this such a perfect day. Boom, 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 boom. Oh, such a perfect day. Da, 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 da. And I believe we were at page number 6. Let's see. Number of even and odd bits. Oof, it's bit related. I hate bits, so let's practice it some more. And hatred is a wrong feeling, you know. So you are given a positive integer n. Yes, we are. Let even denote the number of even indices in the binary representation of n. 0 index with value 1. What? Okay, it's an example. Binary representation. So all zeros are considered even, all ones are considered odd. Something like this. So how do we get a binary representation? It's gonna be like n to s2, right? And we are going to have this array. Return an integer array answer. So it's going to be called answer. Answer me. Answer. And it's going to have 0 and 0 by default. Now let's loop. Do we have to loop? Probably. What if? Yeah. So. Nah. Okay, there are two ways. First of all, let's do like new variable index. Binary. And while the same thing we done earlier, binary index if, well, no, not if, binary index even, then not like this, like this. And else answer 1 plus equals 1. We are going to return answer. All right. We need to convert it to integer because now it's just a string. Oh, yeah. Sorry. What? Even, oh. I did something else. Obviously. Oh. We want to check if index is even or odd. But it's 1 here. or not. What am I doing? Wait a second. I see what the problem is. What do we consider? A first index. We start from the end, you see? It's too hot to think. Well, as always. One. Two. Ah. Yeah, all green. See what the problem was. We have to start from the end of the string. Can we do this without using reverse? The way I wanted to do this? I have a funny solution. Yeah. What else can we do? Well, of course, we can use inject or reduce method. But to use it, we want to create an array from this and to iterate through that array. Now I like this solution better. It's longer, of course, because with inject probably could do a one-liner. I'm not sure. Let's try. N to S2 chars, or we can do, no, we can't do chars. Okay, chars, and let's do reduce starting from 0 0 huh? And we have our answer here, and we have our char here. Not char, by the way. That's a problem. We do not have an index here. What if we do with index? Like this. For now, let's make it not a one-liner, because what do we want? Pretty much the same thing, right? No, we do not need char, by the way. No, of course it's not a good solution. Yeah, and we have to reverse it. We have to use charge. We have to reverse. And now it's not fun anymore. Oh, wait, no. It's not gonna work. Yeah. And we can't do, of course, can't do reverse with index. And we can't do chars with index too. It's gonna be each with index, I guess. Yeah. Well, it's a mess. Right now it's a mess. Of course it's not a great solution. Yeah, and we have to return answer here. It's wrong. Oh. So to hell with it, right? We have a perfectly fine solution here. Well, so many ifs. And I really wanted to start some medium problem today, but I don't know, it's so hot. Oh god. Let's just, take a look what the problem is. Maybe we can spread it, into a few days. Still, let's choose the easiest of the medium problems. Group the people given the group size they belong to. Oh my god, it sounds awful. It also sounds MySQL. No, it's not. So, there are n people that are split into some unknown number of groups. Each person is labeled with a unique ID from 0 to n minus 1. Well, makes sense. You are given an integer array group sizes, where group sizes I is the size of the group that person I is in. For example, if group sizes 1 equals 3, then person 1 must be in a group of size 3. Return a list of groups such that each person I is in a group of size group sizes I. My god. Each person should appear in exactly one group, and every person must be in a group. Okay. So we are going to have results array. I think we need a hash also. Now let's iterate through group sizes. Right? Right. If our hash has a key group size, like say 3, if hash group size length equals group size we are gonna it's not that simple. Nope. Okay, if this is the case, we're gonna add by the way we need index, each with index of course. An index. We're gonna put index here. By the way, if let's do if group size equals 1 we are going to do this. We're gonna put this guy into array and array into results. Else now we add the index and now we check. Oh, it's gonna be bad like this. Just delete. And probably we missed something, of course. Of course. It's green. Huh? Let's submit. Maybe it's gonna be too long. No. First try. Huh? Have you seen that? No one's seen that because I am alone here. But I solved medium problem. First try. That's why they call me Code of Thunder. Well, no one calls me Code of Thunder, but still, I'm very happy with the result. Thank you, I accept imaginary congratulations. And I'll see you tomorrow. Yes. I'll investigate this problem and all the other problems that we touched today, and I'll present to you all the best solutions and approaches for these problems. Now, thank you very much. Goodbye. Until tomorrow.